few extra examples of Pythagoras' formula. The first one is going to be a more algebraic way of looking at triangles, and the second one uses more repeated calculations. But both are important to know by the end of this. So this first triangle, you'll notice something about them, is that we don't know both of the shorter lengths. Okay, so we're going to start by writing out our formula of a squared plus b squared equals c squared, and then substituting in our values. So a squared plus b squared equals 12 squared. Okay. Now, important to know that in these triangles, the a and the b length are the same. That's represented by those dashes. So it's really important to know that a equals b, therefore a squared equals b squared. Because once we know this, we can actually substitute in a squared for that b squared value. So now we have a squared plus a squared equals 12 squared. And when we combine our like terms, we can actually write 2a squared equals 12 squared. Okay? And now this allows us to solve for that single variable. So now that we have 2a squared equals 144, we can divide both sides by 2. So a squared equals 144 divided by 2. Then we get a squared equals 72. Right? Now again, we just have that single variable. So now that we have this, we can just use our square root function on our calculator to find the square root. So a squared equals the square root of 72. And once we've done this, we put that in our calculator and we find a squared equals 8.49 centimeters. Okay, and with these questions, we're going to write our final statement, just so that we make sure that we get all the points in any kind of exams. So because a equals b, a equals 8.49, therefore b equals 8.49 centimeters. Okay, now we're going to do one more example. It's possibly a bit harder, but it's possibly simpler than mathematics in that you're just doing it repeatedly. So again, we're going to write out our formula of a squared equals b squared plus c squared. Now you can do the two deriving formulas from that, which we're just going to plug into our calculator. So we can do c equals the square root of a squared plus b squared. And the good thing about this is we can just put in a string into our calculator. And the other formula is a equals the square root of c squared minus b squared. And again, the good thing about that is you can just put that as a string into your calculator. Now I'm going to highlight the parts of the triangle that we're going to solve for. So that blue line there, that's simply just 37 minus 17. So that'll give us that length from that triangle. So that blue length there equals 20. Okay. Now that we have that hypotenuse length, we can solve for our pink highlighted length using our formula of a equals the square root of c squared minus b squared. Okay, and this is how we're going to do this entire problem. Is that once we have a length, we can solve for the other triangles until we are finally able to work out the length of that small orange piece. Okay, so a squared equals 15.9, well, 0.19, sorry. And again, I'm just going to be plugging these into my calculator instead of going through the whole mathematics because it just takes a little bit too long. So now that we have that a length, we can solve for that purple that I've just highlighted at the bottom of that triangle. And again, it's going to be one of the shorter sides of the triangle, so we just use that formula of a equals the square root of c squared minus b squared. So here that c squared is going to be the length of that pink length we've highlighted, so 15.19 squared minus 12 squared. Okay, plug that into your calculator and you will get a equals 9.31. And now that we have that, we can find the length of that other side of that right angle triangle, or sorry, the other half of that triangle, so the green that I've just highlighted. And that'll simply be the green length equals 28 minus 9.31. Okay, so again, this whole thing just builds on the results that we already have. So 28 minus 9.31 equals 18.69. Okay, and now we're getting to those last couple of calculations. So here we're going to find our last length of our hypotenuse, so this yellow length that I'm highlighting. So again, we're looking for a hypotenuse here, so we're going to use our C formula. So C equals the square root of A squared plus B squared. Now it gets a bit tight over in this corner, so I'm having to cram it in a little bit. So C equals the square root of 18.69 squared plus 12 squared. So C equals 22.21. Okay. Now the last thing we have to do to find that slight orange length down the bottom is subtract the value of our beginning triangle, almost that A side of our beginning triangle, from that whole yellow length. So that length equals 22.21 minus the square root of 17 squared minus 14 squared. Okay, put that into a string in your calculator and you'll get that orange length equals 12.57. Okay, and that's it. So you can write that as a statement. The orange length equals 12.57 units. Okay, and it's important to include that units. So just because we haven't given our actual units we're measuring, so we need to just put that actual word units. Okay, so that's the end of the unit. That's the end of the video. So we'll leave it there for now, and I'll see you next time.